Hello folks, good to be here. Good evening to all of you. I hope you all had a reasonably fun time taking the test, enjoyed yourself in this process. I'm going to spend the next few minutes just shooting the breeze with you. I can see the chat replies, so I'm going to use the time to make sure that the technology is working fine, the audio and video are working fine. You can see me, hear me clearly, all of that. Once we cross all that, once we cross these technology barriers, then we'll go on and discuss this. I can see that you've already been chatting and you've been quite comfortable with the chat interface. I've just closed that chat interface because it was distracting me. Not the chat interface, but some other parts was just popping out. Wonderful. I can now see the chat. Please, I want somebody to say, hey, that you can see me and hear me clearly, that the volume is fine, the video is fine, the visual is fine, all of that. We are at 6 p.m. sharp. I can't wait to start discussing this question. I'm just going to wait for some confirmation. Hi. I have a funny feeling in my stomach. Manoshi Saha. Why is that? Why? It should be all right. Prabhati K. Hello, Rajesh sir. Hello. Subhash Krishna. Thank you. We can see you. Everything is clear, super audio and video, good. Next gen magic. I have a sneaky suspicion I've seen that ID somewhere. Lovely. AV clear. Many thanks to all of you. This is Abhinav Prabhakar, Prabhati K, Mihir Madhavan, Farawa Gaming. I don't even know whether I'm pronouncing it right. Namaste, sir. Namaste to all of you. Lovely. So we are technologically, we've got a green signal, right? So it's lovely to know. I'm going to introduce what we here at PiVerb are all about. I'm Rajesh. So I do almost all the teaching. I like teaching math, as you will soon know. But I like teaching math where the questions are challenging, where we ask tough, tricky questions, where you'll have to figure out something, where you'll have to say, hey, I know this funda, but I don't know the formula for this. But hey, let me hang in there. I'll try different things, do a lot of trial and error, and then figure out what's happening. That idea of math as a toolkit for figuring out different things, I love that. So we've designed this entire course in order to create that magic, where it's not handed on a platter. Right? So all of us know test of divisibility by 4, test of divisibility by 11. But hey, there's an incredibly tough question which uses only one idea, test of divisibility by 11. It can take 15-20 minutes to solve, but it's magical if you finally do it, finally sign off on it. It's a beautiful, tough question. So I want to have a discussion on that question. How will we do that one and the one after that? And so that's what the entire course is about. And so what we do in PiVerb advanced course, we do a lot of questions similar to what you have seen here. A lot of non-routine questions where we take one simple idea and then wrap it around a context which is not formulaic or routine, and then we say, okay, try this out. Right? What is the thing that I want all of you to keep in mind? Right? So be super agnostic to scores. You're all young. You have your big part of your academic careers ahead of you, your entire professional career ahead of you. Your whole life is going to start off now. I don't want you to carry this bugbear with scores and competition and marks and ranks and percentile and all that from now on. We are in what is called a scarcity economy. The global economy itself is super competitive. There's no doubt about it. I'm not saying live in a cocoon and forget about the world. I'm not asking you to be a saint. But don't get carried away by that. The idea of the Olympiad and the class and the course is to have a sense of joy about saying a beautiful question. Have a smile on your face even if you missed out on some good question. Enjoy the solving part and go away saying, hey, I learned something today. And if you at the end of every day you come off feeling, hey, I learned something today, and it's a beautiful idea. And I simply could not have thought about it like this. But when somebody said I could think like that, I was like, oh my God, that's beautiful. Nice idea. I didn't think of it like that. That's nice. And that is the key point of all learning, the aha moment. Hey, nice, good question. My objective and the objective of the entire team here. So the guys who work with me, which is Avinash and Prabha and Raghu and Bala, is to create as many contexts as possible, as many questions as possible, as many problems as possible, where you have a sense of wonder about learning something new, where you feel like, I didn't know that, but that's beautiful. Now I know that, and I'm happier for it. So it is my job, or it is our job to create that. And you guys make sure that you carry the attitude to always have a smile on your face, learn new ideas with endless curiosity, and then keep adding on. The exams and scores and marks are a marker on the journey, but they are not by any means the destination. You should not be saying, look, I need to get 6 in order to have fun. I get 3, good. If I get 4, nice, good. If I get 2, yeah, still good. But I've learned how to solve 5 other questions, which I wouldn't have known. And that's the big point. Right? I'm going to have one look at the chat window. Neil Mantri, is this recorded? Can we watch this later? It should be available on YouTube. You can come back to the same link. You should be able to watch it. Is the result going to be declared today? Of what? Of the elections or the test match? This exam? Yeah, definitely. I still wish you guys wouldn't be so keen to know the result. You will get to know, and I think it should be released later tonight. But don't worry about it. It's incidental. It's for the Philistines. When will we get the results? I've never known a bunch of students who are so keen to know the results. When I was a student, if somebody said, look, your results are out next Thursday, I'd be like, I have freedom till Wednesday. I don't have to worry about it. And then the results come, and then you just take it in your stride, and if it's good, it's good. You go and play with it. If it's bad, you say, you mop around for a day, and you start enjoying life after that. So you're super keen, I see that, and it's a competition element to it, I see that. But hey, we're going to discuss these questions, and there's going to be a more delightful experience than knowing 3 out of 10 and 4 out of 11 and all that. Guru Charan, he also wants to know when we'll get our marks. Forget the marks, my friends. Can we start? Yeah, we can start. Probably 1 or 2 more minutes. I'm waiting for some kind of sign off from our team before we start on this. We say, hey, somebody says, hey, you can start off now, and then I'll jump in. Anand Ramadas, share something about your experience. Probably I should. So I'm an engineer. I finished my engineering. I'm an electrical engineer. I finished my engineering from IIT Madras in 2001, 1997 to 2001. I did BTech electrical engineering. So I did lots of these problem solving things in 94, 95, 96, 97 when I was preparing for my entrance exam and participating in several of these Olympiads. It's a massively fun experience. I recall being humbled by several of these teachers who came to discuss this for the joy of math, and I was getting 1 out of 10 and 2 out of 20. I was disgruntled, but I loved the experience, and I came richer for it. So one of the objectives of this course is to say, learn lots of stuff. Don't worry if you get beaten up by an exam. And so after my engineering, I did my MBA. I did my MBA from IIM Bangalore. And I worked for about 6-7 years, mostly in the financial sector. I was in banking. I was in stock broking, stock trading. And the last 12 years, I've been in teaching. I run an online course for CAT, the entrance exam, and we do PiVerb. PiVerb has been we've been building content for PiVerb for several years. This is what I like doing. So, and we put it together as a course and into a structure more recently, about 2-3 years ago. I think several of you have checked out the PiVerb course. You've seen that, you know what we are about. So that part I'm not going to elaborate on. But any which way, check out the website, sign up as a trial user, see what the solutions are, see how we teach, see the course structure, or ping us, get to know the details. It will be useful. Namaste. I'm going to start off. JSP solution, NCRT math, Olympiad. We'll talk about Olympiads right at the end. There are several Olympiads. I want you to focus on which is the right Olympiad. Did you take part in the INMO, IMO'21, and the IMO? Not the IMO. I took part in the INM, the National Math Olympiad. Didn't go much further beyond that. Lovely, lovely. I'm going to start off with the learning part. The very first question is one of my favorites. And I think we created this question, and we did it twice when we were solving. And we got different answers. And there's the true test of it being a lovely question. And so it cleared that test. Lovely. So what is the smallest natural number that has all the digits appearing at least once and is a multiple of 11. I love breaking down questions and creating simpler variants of this, simpler versions of this, and then thinking about it. And so I want a natural number that has all the digits. Digits is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this number is at least a 10-digit number. And I want the smallest of those possible. So probably I'm looking for a 10-digit number. And I'm looking for a number that is some rearrangement of 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. Rejig it in some form. And the best case scenario, I want a small enough number. So I'm assuming that there's a 10-digit number. I don't have to go to 11 digits. So each digit appearing only once, not at least once, exactly once. And somehow I manage a multiple of 11. And I'm going to break this down further. I'm going to forget the multiple of 11 element. I'm going to say the smallest possible number is 1, 0, 2, 3, 4, 5, 6, 7, 8, 9. And so I know this. I put the 0, I can't start with the 0. So I start with the 1 and then put all the smaller digits early, the bigger digits in the end. I've got myself a number. The smallest possible 10-digit number which has all the digits appearing exactly once. Maybe this number is a multiple of 11, in which case I'll just write down the answer and go. So I'll verify that. How do I test that? This is a beautiful mechanism to check for divisibility by 11. Add odd position digits, add even position digits. And we know this. 1 plus 2, 3, 3 plus 4, 7, 7 plus 6, 13, 13 plus 8, 21. These add up to 21. 0 plus 3, 3 plus 5, 8, 8 plus 7, 15, 15 plus 9, 24. These add up to 24, those add up to 21. I know the test of divisibility. It tells me that I have to do 24 minus 21, which is 3. If this were 0, I would have been true. Nice, true. That's a multiple of 11. Done. And so the test of divisibility says add digits in even positions, add digits in odd positions, find the difference. If the difference is either 0 or a multiple of 11, we have got ourselves a winner. What I mean by a winner is we've got ourselves a number that's a multiple of 11. Beautiful. So this number is not a multiple of 11, so I didn't get lucky. I kind of knew it's not going to be that easy. There's a question appearing in a really tough Olympiad for it. So it's not going to be that easy. But it's given me a nice starting step. I think, hey, I add all these digits, it comes to 21. I add these, it comes to 24. And then I want to know whether the digits are working fine. I've been told that I need to amp up the mic, amp up my own volume. I shall do that. Hello, hello, hello. Hope the volume is super clear. I will speak louder as well. So the digits add up to 21. These digits add up to 24. So 24 minus 21 doesn't work. Now, straight away I know if I add all these digits, all of them together add up to 45. I'm splitting 45 into two parts, even position digits, odd position digits, which is all nice and lovely. But the moment I do that, I recognize that I can never split it equally. I cannot put 22 here, 23 here, then my difference will be 1. 24 and 21, difference will be 3. I cannot put 22.5, 22.5. 45 is an odd number. So if I add these digits and add these digits, the difference is never going to be 0. That's my first takeaway. And so I straight away sense that, hey, this is interesting, but the difference is not going to be 0. So I have to figure out a mechanism where I write down 10 digits in some form, where I add these digits and I add these digits. And my difference is going to be 11, not 0. It could be 11, 22, 33, but 11 seems reasonable. 22 is probably too big. Let me worry about it if 11 doesn't work out. But it's not 0. I know the difference is not 0. Right? So all these numbers, let's say they add up to x. All these they add up to y. X plus y is 45. Total sum of all these digits is 45. 21 plus 24 was 45. 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 is 45. 21 plus 24. Totally it is 45 sitting in. The difference is 11. How could it be 11? X plus y is 45. It could be 25 and 10, 25 and 20, in which case the difference would be 5. Or 26 and 19, the difference would be 7. 27 and 18, difference would be 9. 28 and 17, difference would be 11. What am I doing? I'm increasing one, decreasing the other. right? So, or my two sums should be 28 and 17. Now I've got myself something. So I'm going to restart this whole question. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have one set of 5 digits here, another set of 5 digits here. I want the total number to be as small as possible, and I want some of these to add up to 28, remaining to add up to 17. If I have one set adding up to 28, remaining will automatically add up to 17. If I have one set adding up to 17, remaining will automatically add up to 28. And I want this number to be as small as possible. So I'm going to say, hey, let me put 1, 0, 2, 3, 4, 5, and then see if I can just play around with these digits to achieve my objective. And so 1 plus 2 plus 4, these add up to 7. 0 plus 3 plus 5, these add up to 8. 1, 0, 2, 3, 4, 5. I'm just going to play around with these. So I want my one total to be 28, another total to be 17. Right? My total is 8. I have to take it to 28. My last two digits have to give me 20. That's not possible. I have 8 and 9. Even if they add up, I'll get only 17 as total. This 7 is also not going to 28. What this is telling me, I simply cannot achieve my objective if I have 1, 0, 2, 3, 4, 5. I cannot just change around, play around with 6, 7, 8, 9 and get my desired totals. These add up to 8, those add up to 7. That is simply not going to work. So I know my smallest number is not 1, 0, 2, 3, 4, 5 something. I cannot have 5 here. That doesn't work. So let me simplify. Let me put it as 1, 0, 2, 3, 4, 1, 2, 3, 4, 5. 2. These 3 I add. These 2 I add. And then to this I'll have to add this and this. 1, 0, 2, 3, 4, 0, 3, and then I'll have to add this, this, and this. I'm going to check this out. I'm going step by step. I did 1, 0, 2, 3, 4, 5, didn't get anything. I went to 1, 0, 2, 3, 4. I'm going to see if that is possible. If I add these, let me just erase this so that it's not confusing. Let's come from the previous thing. 1 plus 2 plus 4, these add up to 7. 0 plus 3, this adds up to 3. Right? I have to add 2 more digits, right, and take the total to 28 or 17. I add 2 more digits, taking it to 28 is tough, maybe I can take it to 17. These 2. Or 0 plus 3 is 3, these 3 I add, and I can, now if I can take this total only to 17, this total has to go to 28. 3 more digits and I have to take the total to 28. So automatically tougher. So I'm going to attack only this. 1, 0, 2, 3, 4. So 1 plus 2 plus 4 is 7. I know 1, 0, 2, 3, 4, 5, I cannot achieve anything. 1, 0, 2, 3, 4, let me see if I can achieve something. So I need to add 1, 2, 4, I get 7, and then I add these 2. I have to take the total up to 17. So I need to find 10 more. But 1, 0, 2, 3, 4 has been taken. Even if I put 5 here and 6 here, that is 11 more. The minimum total this will go to is 18. Because this one can go only to 17. It cannot go to 18. That doesn't work for me. So 1, 0, 2, 3, 4 is tricky. With 1, 0, 2, 3, 4, these 2 digits should give me total of 10. 7 have been accounted for. I need to go to 17. That's not possible. Even if I put 5 here, 6 here, my total will go to 18. So this also doesn't work. Starting with 1, 0, 2, 3, 4, 5, I cannot find a number. Starting with 1, 0, 2, 3, 4, I cannot find a number. Let me go to 1, 0, 2, 3. And then think from there, where do I go? 1, 0, 2, 3. 1, 0, 2, 3, 4, I don't get anywhere. Maybe 1, 0, 2, 3, 5 is possible. That's something that I need to think. 1, 0, 2, 3, 5. Maybe that can work. I put 1, 0, 2, 3, 5 here. This adds up to 8. Maybe I can go to 17. Can I? 1, 0, 2, 3, 5. This adds up to 8. I have to go to 17. 8 to 17 is 9 more. Even if I put 4 and 6, that is 10. Simply doesn't work. I cannot get to 17. If I have 1, 2 sitting in the bag, I cannot squeeze in enough to go to 17. Right? So 1, 0, 2, 3, 4 doesn't work. 10235, 10236. Work 10236. I'm just going to think about this. So 1 plus 2 plus 6 is 9, which is good. I need to get to 17. 17 minus 9 is 8. I need to get a total of 8 remaining. 12023 add out. 4 plus 5 is 9. Doesn't work. So 1023 something. 10234, 10235, 10236, 10237. 10237, this adds up to 10. I need 7 more. Doesn't work. This doesn't work either. Adding up to 17 like this is tricky. And I'm going to have one look at the chat window just to see whether there is something that is going on here, that you guys have already found the answer. There some of you are already jumping with joy. Super. No, you're discussing it, but you do not have the answer yet. It's a super tough question, right? So 1023 doesn't seem to work. So I'm going to start with saying one 0 2 3 7 2 3 8 didn't work. So let's say put 1 0 2, maybe put a 4 here. Now we'll think 1 plus 2 plus this plus this plus this we have remaining. 0 plus 4 plus this we have remaining. 1 plus 2 is 3. 0 plus 4 is 4. 1023 we didn't get anything. With 1024 maybe we'll get somewhere. 1024, this adds up to 0 plus 4 is 4, 1 plus 2 is 3. From 4 we can go to 28. That means we'll have to find a remaining 24 somewhere. From 3 we can go to 17. We need to find 14 more somewhere in 3 digits. 1024, we have to go to 24. 24 can be got by saying, let me just think the number of digits, one more digit here. 1, 2, 3, 4, 5, one more digit here. So 1024 all the way till 28. I need 24 more. 24 could be 7 plus 8 plus 9. That can work. So 1024, 7, 8, 9 add up to 24. I still have 7, 8, 9 remaining with me. The moment I put that, the remaining will have to come here. It will automatically work. Or I can have a number which is 1, 0, 2, 4, dash 7, dash 8, dash 9. So 0 plus 4 is 4. 7 plus 8 plus 9 is 24. 24 plus 4 is 28. All good. The remaining should be 17. 1 plus 2 is 3. 3 gone. The next digit is 3. That's still remaining. The remaining digits are 3, 5, 6. 3 plus 5 plus 6 add up to 14. Plus 3, 17. This works. I should put them in ascending order. Put the smaller digits earlier. This will work. 1, 0, 2, 4, 3, 7, 5, 8, 6, 9. That works. Taking this to 17, this to 28 does not work. If you take this total to 28, 3 digits I need to add up to 25. The highest total 3 distinct digits can have is 7 plus 8 plus 9. 9, 8, 7. That is to 24. This total cannot go to 28. Only this can go to 28. With that going to 28, 1023, we couldn't achieve anything. 1024 is the next smallest. With 1024, this is the best case scenario. We are through. The number is 1024375869. 1 plus 2 plus 3 plus 5 plus 6. This adds up to 17. 0 plus 4 plus 7 plus 8 plus 9. 24, 28. This adds up to 28. 28 minus 17 is 11. This number is a multiple of 11. No larger, no smaller number than this can be found, or the smallest natural number that has all the digits appearing at least once, and that also happens to be a multiple of 11 is this one. 1024375869. Absolutely delightful question. It took us a long time to solve. Super difficult. But go through this and try it completely. Trial and error, some method, some figuring out, going step by step, seeing that 1023 doesn't work, trying with 1024, maybe that works, maybe that doesn't work, keeping on hanging in there and doing. It's a beautiful question, really tough question. 1024375869. Why we have given this number among all the test takers? less than 2% or around 2% have got this right, which kind of tells you how difficult this question is. It's also not something that you can guess. So from sheer fitness, the number, the answer has to be 1 to 10, everybody takes a guess and some answer is right. You can't easily guess this. Right? It's remarkably tough that only 2% have got it. But the 2% who have got it have spent probably 10-15 minutes trying to somehow make sense of this and have hung in there, gone step by step, methodically, and got it right. So hats off to those of you who hung in there. I'm actually not that worried about whether getting it right or wrong. Heavily trial and error, some method driven, mixing both, knowing when to plug in a formula, when to do trial and error, when to change from one to other, that is super important, super crucial. Right? So lovely. Lovely, super. I'm going to go to the next one. A is the highest common factor of 96 plus B and 187 plus B. A is greater than 1 and the scope prime with 504. Find the smallest natural number value B can take. A, there's B, and then there's HCF of these two numbers. All of these questions I like by starting saying, let me put a value for B. A is a natural number, B is also a natural number. I'm going to put B equal to 1. So I'm talking about 97 and 188. 97 is prime, 188 is 94 into 2. The HCF of these two numbers is 1. I'm putting B as 1, put B as 2. This becomes 98, 189. This is 2 into 7 into 7. This is a multiple of 3. 3 into 63. This is interesting. 2 into 7 into 7. This is 3 into 63. 3 into 21. So 3 cube into 7. This is 2 into 7 square. Or the HCF is 7. So nice, lovely. So we put B as 2. This is a multiple of 7. This is a multiple of 7. So HCF is 7. A is greater than 1 and the scope prime with 504. A is greater than 1, we've got ourselves a 7. Maybe this is the answer. But A is scope prime with 504, or A has nothing in common with 504. So I would be very disappointed if there's something in common between 504 and 7. Then that won't be my answer. 7 won't be my answer. Then A is not 7, B is not 2. Doesn't work. Let me check this out. Right, so A is 504 is 2 into 252. 2 into 2 into 126. 2 into 2 into 2 into 63. Oops. This is 7 into 9. I know that. So this is 2 into 2 into 2 into 7 into 3 square. This has a 7 in it. A cannot be 7. A is scope prime with 504. A is not 7. Damn. This doesn't work. This doesn't work. I put B equal to 3. This number becomes 99. This number is 190. This is 9 into 11. This is not a multiple of 9. This is not a multiple of 3. This is not a multiple of 11. They are co-prime. I put B equal to 4. This becomes 100. This becomes 191. Nothing in common. Nothing here. Right? Now I'm thinking, hey, interesting. But I can't do this. I can't keep doing 1, 2, 3, 4, 5, 6. I need to find a method. And so A is the HCF of these two numbers. And so I'm going to call this 96 plus B as M. 187 plus B as N. A is the HCF of M and N. Brilliant. So, interestingly, A is the HCF of M comma N. Or A divides M, A divides N. We know A is greater than 1. So A is some number which is a factor of M, which is a factor of N. Or M can be called as A into P, N can be called as A into Q. So 96 plus B is AP, 187 plus B is AQ. Why am I doing all this? For one beautiful idea, which is if A divides M, A divides N, that means A will divide M minus N. This minus this, this minus this. If I subtract N minus M, that will be AQ minus AP, A times Q minus B. Or if I subtract this from this, 187 minus 96 is 91 is A times Q minus B, or A divides 91. If A is the HCF of two numbers, then A definitely divides the difference between the two numbers. I am through. A divides 91. A is a factor of 91. 91 factors of 91. 91 can be written as 1 into 91, 13 into 7. A has to be 1, 7, 13 or 91. One of these four is A. That much I know. A is not 1. A is greater than 1. A is not 7. Why? Because A has nothing in common with 504. 504 is a multiple of 7. That is out. So A is either 13 or 91. It could be 91. It could be 13. I want to find the smallest natural number value B can take. On the small value, I'm going to put A as 13. I'm going to say if A can be 13. Let me now say that the smallest, the highest common factor of these two numbers is 13. Now let's work with this. So 96 plus B, 187 plus B. Let's say both of these are multiples of 13. 13 into 5 is 65, 13 into 7 is 91, 13 into 8 is 104. Let's see if that works. 96 plus something should give us 104. This something is 8. I'm going to add the same thing there. 187 plus 8 is 195. 195 divided by 13. 1 time. 15 times. So this is 15 into 13. This is 8 into 13. So 13 is indeed the HCF of 104 and 195. A could be 13, which means B could be 8. The key thing here, if A is the HCF of M and N, then A is the HCF of M and M minus N. A is a factor of M, A is a factor of N, A is definitely a factor of M minus N. Should look at this and say 96 plus B, 187 plus B. These two numbers are 91 removed. They have a distance of 91 in between them. That means A should be a multiple of that 91. I'm going to do this idea in a slightly different way as well. I know you've got the answer. Answer is 8. 12% I've got it right. If you have a number line, right? Somewhere on this number line, 96 plus B will be there. Somewhere on this number line, 187 plus B will be there. We are saying A is a factor of both of these, not just a factor, highest common factor. That means if you recite A tables in your mind, think about that. A divides both these numbers. I have a 0 here. If I say A, it has to sit here. And then I do A, it has to hit here also. Or this distance, which is 91, is a certain number of times A, or A is a factor of 91. A divides both of these numbers. A into something, keep jumping in steps of A, you will hit here. Keep on jumping, you will hit here also. That means from here to here, I am making a certain number of jumps of A, or this difference is a multiple of A. Done. That means RA is a factor of 91. Either 1, 7, 13 or 91. It's not 1, it's not 7, plunk in 13, you're through. Fine. Lovely. I'm just going to have one look at the chat. A should be greater than 1. A equal to 13 works. If you put A as 13, B equal to 8. Both work. Lovely. So I'm going to go to the next one. 2 tough questions. Hopefully, the next question is slightly easier. Fine. 1 into 2 into 3 into 4 into 5 till n is n with an exclamation mark. It's not n. It is called as n factorial. What is the smallest value of n such that n factorial is a multiple of 891? 891 is such a large number and I'm already worried. I'm going to, all of these questions were especially questions that I don't understand the idea. I love breaking it down by saying, hey, let me write down a few numbers. 1 factorial is 1. 2 factorial is 1 into 2. 3 factorial is 1 into 2 into 3. 2 factorial into 3 is 6. 4 factorial is 3 factorial into 4, 24. 5 factorial, 24 into 5, 120. This is 1 into 2 into 3 into 4 into 5 will take us here. 6 factorial, 120 into 6, 720. 7, I'm not going to keep writing this, the numbers are becoming larger and larger. Right? So I can't verify this like this. I can say none of these numbers is the answer. 891 is more than this. I can also say 891 factorial. If I say 1 into 2 into 3 into 4 into 5 into 6 into 7 into 8 into 9 into all the way till 891, that number will definitely be a multiple of 891. 891 works. But 891 is a good n, but it may not be the smallest value of n. Maybe some other smaller factorial works and I can get to 891. Now I'm going to investigate this 891. 891 is not some random number. Let me see if I can factorize 891. How do I factorize 891? 891 is odd, so it's not a multiple of 2. 8 plus 9 plus 1 is 18, so the number is a multiple of 9. So I can divide this by 9. 89 goes 81 9 times. 81 9 times. I can divide this by 9. So 891 is 9 into 9 into 11, or 3 into 3 into 3 into 3 into 11. So 891 is 3 into 3 into 3 into 3 into 11. So in my factorial, I should somehow get 3, 3, 3, 3, 11. If my number is a multiple of 3 into 3 into 3 into 3 into 11, somehow I get that in n factorial, I am through. 3 into 3 into 3 into 3 is 81. So maybe 81 factorial will work. If I go till 81 factorial, 1 into 2 into 3 all the way till 81, then this is 81 factorial. This number is definitely a multiple of 81. And along the way in my journey, I would have crossed 11. This number has 11 in it and has an 81 in it. This number will be a multiple of 81 into 11. This number will be a multiple of 891. N could be 81, but I'm still not sure. I feel like I've gone too high. Maybe I can accommodate it even smaller. Because 81 is 3 into 3 into 3 into 3. Maybe I don't need to go till 81. Suppose I write it as 1 into 2 into 3 into all the way 11 into 12 all the way to say 27. Hypothetically, 27 is 3 into 3 into 3, 3 cube. There is a 3 here. So this number will be a multiple of 3 power 4. It will have 4 3's in it. It definitely has 11 in it. This number will be a multiple of 3 power 4 into 11. I've got 891. So I don't need to go till 81. I can achieve with 27. Maybe I can do even better. Now I know the method. I know that everywhere I pick up 3's into my product, I need to keep in mind, every time I pick up 4 3's and 1 11, I'm through. So now I'm not going to do by trial and error. I'm going to think about where does my 3 come. So 1, 2, 3. This gives me a 3. 4, 5, 6. This gives me a 3. 7, 8, 9. This gives us a 3. 10, 11, 12. This gives us a 3 and 11. 12 factorial will work. 12 factorial will work because this gives us a 3, another 3, another 3, another 3. 4 3's and 11. 12 factorial will be a multiple of 891. Am I missing something here? We are still missing something because this gives us a 3, this gives us a 3, this gives us 2 3's. So, hey, come to think about it, I don't even need the 12. I can stop at 11. Why? Because there's a 3 here, a 3 here, and 2 3's here. By the time I do 1 into 2 into 3 into 4 into 5 into 6 into 7 into 8 into 9, my number is a multiple of 81. 81 has already been accounted for. I only need to get the 11. 11 is prime. 11 can come only from 11. But if I now multiply all numbers from 1 to 11, 3 and 6 give me 1, 1, 3. 9 gives me 2 3's. So 3 into 6 and 9 is multiple of 81. And I get 11. 81 into 11 is 891. With 11 factorial, I have a winner. I don't have to even worry about looking for a smaller number than this. Because before 11 factorial, we simply cannot get 11. 11 is prime. 1 into 2 into 3 into 4 into 5 into 6 till 10. How many ever times we multiply? 1 cube into 3 square into 5 power 7, whatever. You can never get it 11. 11 can come only if there is 11, multiple of 11. So till 11 factorial, it's impossible to get 11. At 11 factorial, we get 11 and we get our 4 3's that we need, 3, 6 and 2 3's and 9. So 11 factorial is a multiple of 891. Lovely. Next gen magic has gone from really confident to maybe it is right really quickly. This is nice. I like this. A super tough question. If 22% have got it right, that's brilliant. Again, don't worry if you don't get questions right. If you get the idea and you say, okay, next one, something like this, I can have a crack at it. That is important. The takeaway is the idea of learning something from it, not getting anything right. P plus 50, P plus 100 are all prime numbers. Find the largest value of P cube minus 2. P plus 50, P plus 100 are all prime numbers. Find the largest value of P cube minus 2. Nice stuff, right? So let me do this. What we do usually, let's put some P is prime. P equal to 2 won't work. 2 plus 50 is not prime. 2 plus 100 is not prime. I'm going to put P is 3. 3 plus 50 is 53. 3 plus 100 is 103. This is prime, this is prime, this is prime. Lovely. All three are prime. So P could be 3. Could be 3. In which case, P cube minus 2 would be 27 minus 2, which is 25. I'm not saying we've got the largest value, but we've got one value. P equal to 3 works. If P were 3, P cube minus 2 is 25. We've got ourselves one value. Nice. Now let's find another. Next prime number is 5. 5 won't work. 55 is not prime. Next prime number is 7. 57 is not prime. 5 plus 7 is 12. Next prime number is 11. 50 plus 11 is 61. 100 plus 11 is 111. This is not prime. P equal to 13. 13 plus 50 is 63. This is not prime. I want P plus 50, P plus 100 to be all prime. Let's put P equal to 17, 67, 117. This is prime, this is not prime. P equal to 19, 69, oh this is not prime. P equal to 23, 73, 123, this is not prime. I'm having trouble. I thought I'll find 1 more, 2 more, 3 more and be able to find the largest value. Now I'm already thinking maybe there are not too many values. Maybe, just maybe, there is no other value. And so P equal to 3 is the only possibility where all 3 are prime. Now I'm going to say maybe that is the case. Now I'm going to prove that. How do I prove that? Let me see a pattern. P equal to 5, P equal to 55, P equal to 105. This is not prime, this is not prime. 7, 57, 107 is not prime. 11, 61, 111 is not prime. 13, 63, 113 is not prime. Why are these numbers not prime? 57 is 3 into 19. 111 is again 3 into something. 1 plus 1 plus 1. 63 is 3 into something. 117 is 3 into something. 69 is a multiple of 3. 123 is a multiple of 3. It's a multiple of 3 sitting here somewhere. Right? Now I'm going to see if I can extrapolate this. I'm going to reframe this question. P plus 50, P plus 100 of these 3, somewhere there has to be a multiple of 3 sitting. That's my hypothesis. How do I prove this? How do I go about thinking about it? I'm going to draw the number line. I'm going to select some P here. I'm going to select P plus 50 here. I'm going to select P plus 100 here. And you will learn modulo arithmetic and all kinds of fancy remainder theorem and all that. But I'm going to do it by a very old-fashioned method. Right? So from P plus 50, I keep on going in steps of 3. 3, 3, 3, 3, 3, 3. So P plus 47, P plus 44. Keep subtracting 3. Right? What will I finally hit here? Think about that. From P plus 100, I keep on going in steps of 3. From P plus 100, if I keep on going in steps of 3, I won't hit P plus 50. The difference is 50. 50 is not a multiple of 3. From P plus 50 to P, I won't hit P plus P. 50 is not a multiple of 3. P plus 50, from 50, if I keep subtracting 3, where can I go to? Multiples of 3. P plus 3 into 16 is 48. So if I keep on doing this, I can go till P plus 2. Doing the same thing this side from P plus 100. From P plus 100, I keep subtracting 3. 3 into 33 is 99. Here, I can go all the way till P plus 1. Lovely. Beautiful idea, super important idea. P plus 1, P plus 2, the 3 consecutive numbers. P plus 1, P plus 2, 3 consecutive numbers. Now, if out of these 3, one of them has to be a multiple of 3. In any 3 consecutive number, there is one multiple of 3. P plus 1, P plus 2. If P plus 1 were a multiple of 3, P plus 50 will be a multiple of 3. If P plus 2 were a multiple of 3, P plus 100 will be a multiple of 3. Yes or no? I'm going in the other way around. Sorry. I've done this in a hurry. If P plus 1 were a multiple of 50, P plus 100 will be a multiple of 50. If P plus 2 were a multiple of 50, P plus 50 will be a multiple of 50. Or out of P plus 50, P plus 100, one of these has to be a multiple of 3, for sure. So, all 3 of them cannot be prime. But hey, we've been told all 3 of them are indeed prime. So, what is the possibility? One of the 3 has to be the prime number 3 itself. That's the only possibility. Or P equal to 3 is the only scenario where this is possible. So, if P were any number greater than 3, P plus 50, P plus 100, of these 3, one of them will be a multiple of 3. If it's a multiple of 3, it cannot be prime. So, all 3 cannot be prime. We've been told all 3 are prime. Of these 3, one of these is a multiple of 3, but all 3 are prime. There's only one prime number that's a multiple of 3, 3 itself. Or one of these 3 has to be 3. These 2 cannot be 3. The first one has to be 3. Or our number P has to be 3, which means P cube minus 2 has to be 25. But it's not just the largest value, that is the only value possible. P equal to 3 is the only solution. Proving that, establishing that, that is the tricky part. Right? Lovely. I'm just going to have one look at the chat. Lovely, lovely, lovely. So I think some of you are discussing modulus. Modular arithmetic is super useful. We're going to be covering this in the next few classes with PiVerb Advanced. So we're going to discuss this, and we've discussed some elements of this in PiVerb Advanced course. We will be adding modulus also to that thing. If you know modular arithmetic, this is super useful. It becomes more attemptable. I'm not going to solve this using modular arithmetic, and so that's not the objective. I know several of you don't know modular arithmetic, but I want to think in terms of going in steps of 3, P plus 1, P plus 2. P plus 1, if I keep on adding 3, I'll hit P plus 100. P plus 2, if I keep on adding 3, I'll get P plus 50. So P plus 1, P plus 2 and P plus 50, P plus 100 are similar. One of those 3 has to be a multiple of 3. That's the takeaway. That's all we need. Right? Lovely. I'm going to go to the next question. Four friends A, B, C and D go out to play. In how many ways can we create a contest of 2 versus 2 from within this set of 4 people? Very nice question, one of my favorite questions. We had a tougher version of this, and we said, look, we should not make it so difficult, so we dialed it down. It turned out it probably became not that difficult. A, B, C, D go out to play. We want to select a contest of 2 versus 2. We could have A, B versus C, D. AC versus BD, AD versus BC. With A, I could pair up B, I could pair up C, I could pair up D. So A and B versus C and D, A and C versus B and D, A and D versus B and C. 3 possibilities. Right? So, or what are we saying? From 4, select some 2, AB, AC, AD. The other 2 automatically form the operand pair. AB, AC, AD, you could select BC, BD, CD. I have to select 2 out of 4. The other 2 automatically select themselves. And how many ways can I select 2 out of 4? AB, AC, AD, BC, BD, CD. So BC gets selected, BC versus AD, BD gets selected, BD versus AC, CD versus AB. The only catch here is these 3 matchups, and these 3 matchups are identical. So we don't have 6 matchups, we have only 3. AB versus CD and CD versus AB are same. So from 4, we select 2. And how many ways can there be done? AB, AC, AD, BC, BD, CD. That we know. We can list everything down and count. But that doesn't mean there are 6 matchups. There are only 3 matchups. If I have AB here that is selected and CD that is remaining, having CD selected and AB remaining, the same. AB are playing against CD. Other way to think about it, we have to pair A with somebody. Suppose you are A, you want to play 2 versus 2. You can be with B, you can be with C, you can be with D. That's it. All combinations have been counted. So there are 3 ways of doing this. Just remember, not 6 ways, only 3 ways. AB versus CD, AC versus BD, AD versus BC. Right? Lovely. 3 ways of doing this. Lovely. So I'm going to give you a quick outline about the course. We offer what is called as the PiVerb Advanced course. It's a very beautiful course. We've taken a lot of effort to outline this course. What do? We do a lot of non-routine questions, go beyond what you see in school. Probably the Olympiad is a good kind of a teaser for that, a sample for that. And so what we run a learning track where we say, hey, you can learn all these ideas brick by brick inside the course. And then we do a non-routine problem solving track. So what we're doing today on this session on YouTube, we do one session like this every week in the course. There's a test of 10 questions, all non-routine, all different, all tricky, interesting, not obvious. And then we discuss those 10 questions. We do this every single week. Right? The questions in the Olympiad are a mixed bag. Inside the course, when you take up the full year course, each of them sits within a pattern. We teach some theory, do a non-routine test, discuss that. Teach some theory, do a non-routine test and discuss that. That's the objective. It's a wonderful course. Every week we meet and discuss this. There's relevant stuff to learn, like modulus, which I think Suradip Das was talking about. Or some idea on counting, writing it as 4C2, 5C3. That part will teach. The teaching part is one component and the non-routine problem solving is the second component. Between these two, we cover the whole ground. So it's a lot of fun. During the class session, we have sessions like this where we discuss and have a chat. Several of our students are here attending this session. So any one of you saying like, hey, this looks like fun, I can do this. Once a week, 1 hour of test and 1 hour of discussion, right up my alley. Please reach out to us, fill that form, and we'll be able to have that. I'm not done with the session, by the way. I'm going to continue with this because we've discussed only 5 questions. The remaining 5 we will discuss immediately. I've just taken a short time out. I don't want to bombard you with questions. You're new, you're doing this for the first time. So I don't want to intimidate you solving question after question after question. So we're just shooting the breeze and saying this is a wonderful course. Those of you saying, look, I like math. I like the idea of doing new, different, non-routine, atypical, slightly wacky questions. This is right up your alley. We'll not only do lots of questions to kind of digest the idea, we'll give you the underlying material to gear yourself up, theoretically, fundamentally, to handle these questions. Right? So we have 2 batches, one for classes 6 and 7, that happens every Thursday, one for classes 8 and 9, which is you guys, which happens every Tuesday. There's a nice little form here, just click there, fill that in, and then you can check out the course, you can attend a sample class, all that you can do. Lovely. Contact number is available. You click on the form, contact number is available on the description to this video. You can ping and any one of us will be able to give our contact number. I think Jaidev Balaji has been kind enough to share the number, which is nice, thank you. Or if you, there's a pinned comment where you can just find the thing, which pinned comment is right at the top. Just click there, you'll be able to fill that in. What's the duration of each class? Each class goes for 2 hours, 6 to 8. 6 p.m. to 8 p.m. here. 1 hour of test, 1 hour of discussion. So you guys took the Olympiad over the weekend. We're discussing it today. In a typical class, the 6 to 7 part will be test, 7 to 8 will be discussion. 1 hour test, 1 hour discussion. Today's discussion is going to be beyond 1 hour because these questions are slightly tougher, and all of you who are participating in this, you want to make sure there's slightly more time to digest the format. Our students, they know this. I'm rattling along and going, saying, look, you know modulus, we do this, p plus 50, p plus 100, you can finish that. I'm going at might be able to go at a slightly faster clip. Right? Otherwise, 1 hour of test, 1 hour of answering. Any trial class available? This is from Prabhakar. Yeah, this is a trial class, Prabhakar. Effectively, this is a Prabhakar. Is it free? It's not free. Of course, it is not free. It's a really tough, really interesting, really intriguing course. So it's a giant package. We do tons of stuff over a full year. Most definitely, it is not free. We cannot afford for it to be even at the price it is right now. It is not free. We cannot afford for it to be free. This class is free. The sample is free. Timing 6 to 8. For 8-9 class, it is 6 to 8 every Thursday, 6 to 8 every Tuesday. 8th and 9th channel is Tuesday, 6th and 7th is Thursday, 6 p.m. to 8 p.m. There is a regular course for PiVerb basics, the absolute simple, whatever you cover in school, that as well is Vibhuti. That also you can find details on the website. That is everything that you do in school is mimicked question for question, idea for idea, funda for funda inside on a platter. All our DAV students already know that. So you know what PiVerb basics is about. It's not PiVerb basics, it's PiVerb advanced. No rewards for winner. There will be rewards for winner, Abhinav. We will send some reward across, but the reward, you all know, you guys have done this. The idea of solving and getting it right and saying, look, I scored 6 questions, I never thought I could, that is brilliant. Or I tried only 2, but I now understand how to approach 7 of them, I'm happy. That is the reward. Your rewards are going to come 15 years from now when you sit in a meeting and you understand everything that's being discussed because you've done tons of questions that open up your mind. And so, but there are definitely rewards and prizes. All of that is going to be there. Don't worry about it. Alpha 3 Gamer, 8 and 9 Tuesday, not 6 to 7, 6 to 8, my friend, 6 to 8. 6 to 7 is the test, 7 to 8 is the discussion. Payal Mukhopadhyay, do we conduct this even offline? I doubt it, Payal, because the online format really works for us to set the pace and get the discussion going. I don't know how long we'll have COVID. So post-COVID, we'll think about it, but mostly nothing online, nothing offline. Ashwin Kumar, Satish Kumar, I like your teaching. Thank you. Instructions will be given to see the marks. Definitely, yes. What are the prices? Work is its own reward. We are having the prize right now. Yeah? Discussing these questions. Remaining questions we're going to start now. That is the most relevant question. Let's do this. The largest positive integer, which cannot be written in the form 5m plus 6n, where m and n are positive integers. Anytime I have this cannot be written in the form, I'm like, look, why do I want to think about cannot be written? I'll think about can be written. What can be written? 5m plus 6n. I'm going to think about what can be written in this form. So, m and n are positive integers. I can put m equal to 1, n equal to 1. 5 into 1 plus 6 into 1, 5 plus 6, 11. I can write 11 in terms of 5m plus 6n. I cannot write 10. The smallest value m can take is 1. Smallest value n can take is 1. When m is 1, n is 1, I get 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 cannot be written. The largest positive integer which cannot be written, 10 cannot be written, that I know already. Maybe some other numbers also cannot be written. What can be written? 11 can be written. What is the next number that can be written? I can keep n as it is. I can put m equal to 2. Or I can keep m as it is, put n equal to 2. M is 1, n is 2, 11 plus 6, 17. N is 1, m is 2, 10 plus 6, 16. So I can write 11, I can write 16, I can write 17. Now I know I can generate a bunch of numbers that can be written. How so? Very simple. I put n as 1, m as 2, I put m as 3, 4, 5, 6, 7, 8, right? Or 11, 16, 21, 26, 31, 36, 41, 46. All of these can be written. What am I effectively doing? I put m equal to 1, n equal to 1, I got 11. I can keep adding 5 to it. All those numbers I can write. 16, 21, 26, 31, 36, 41, 46, 51, 56, 61, 66, 71, 76. All of those I can write. All I'm doing, n is 1, I'll keep adding 1 more to m. And if n is 1 and n is 2, this is 17, n equal to 2, 23, 4, 29, 5, 35, 6, 41, 7, 47, 8, 53, and so on. I've got one sum. I can keep adding 5 to it. I'll be able to generate everything. I can keep adding 6 to it. I'll be able to generate everything. Beautiful, brilliant. Now, this entire sequence, I've got this entire sequence I've got. I can do better than this. I can add m equal to 2, n equal to 2. That will make it this plus 6, 22, or this plus 5, 17, 22, 27, 32, 37, 42, and so on, 47, 52. I can add like this, 16, 22, 28, 34, 40, 46, 52, 58, and so on. I can add like this, 28, 33, 38, 43, 48, 53, 58, 39, 44, 49, 54, 59, 64, and so on. Nice. I can fill the entire grid of possible numbers. Some numbers are still not possible, but I'm already getting a pattern. I'm thinking only in terms of a pattern. What can I find? And so any number k I have, k plus 5 I can get. Brilliant. If I have a k, then this means k plus 5 I can get. I can get k plus 6. If I have a number k, I can get k plus 5, I can get k plus 6. So if I have 103, I can get 108, I can get 109. This is brilliant. And so what this means is, if at any point of time I have 5 consecutive numbers, suppose hypothetically I have 100, 101, 102, 103, 104. 100 will make sure 105 is there, 101 make sure 106 is there, 107 is there, 108 is there, 109 is there, plus 5, plus 5, plus 5. The moment I have 5 consecutive numbers, I'm through. Every natural number after that I can get. If I have 100 to 104, 105 to 109 can be generated, 110 to 114 can be generated. Anytime I have 5 consecutive numbers, I'm through. I've got myself a winner. Now let's go back to this. 11, after that we have only 16, 17, 12, 13, 14, 15 are not possible. And then I have this number, 20 is not possible, but 21, 22, 23 are possible. And so 3 in a row, I've got 3 in a row. But the highest number that is not possible till here is 20. 20 is not possible. 21, 22, 23 are possible. 24 is not possible. And so 25 is also not possible. 25 is 5 into 5. But hey, if I have 5 5s, I have no 6s. That's not possible. The highest number not possible so far is 25. Is 26 possible? Yeah, 26 is sitting here. 27 is sitting here. 28 is sitting here. 29 is sitting here. Lovely. If you notice this is plus 1, plus 1, plus 1, plus 1, plus 1, plus 1, plus 1. Because I'm effectively taking off a 5 and adding a 6. Taking off a 5, adding a 6. 26, 27, 28, 29 are possible. 30 is not possible. 30 is not possible. That's a shame. Why is 30 not possible? 30 is either 5 into 6 or 6 into 5. I can have m as 6 and n as 0, or m as 0 and n as 5. Both ways I can get 30, but I want both of them to be positive integers. 30 is not possible. 31 is possible. 32 is possible, 33 is possible, 34 is possible, 35 is possible. I am through. 30 doesn't work, but 31 to 35 work. If 31 works, 36 works. 32 works, 37 works. To this I add 5, I add 5, I add 5, I add 5, I add 5. The next 5 numbers are there. So if 31 to 35 everything works, 36 to 40 everything will work, 41 to 45 everything will work, 46 to 50 everything will work. From 31 every number is possible, every natural number. Just before 31 we have a 30 which is not possible, or the largest number that cannot be written is 30. The key thing here is to say I go in steps of 5. So the moment I have 5 consecutive numbers, I am through. So I am going to look for 5 consecutive numbers that work. 5 consecutive numbers that work, 31 to 35. 30 doesn't work, I've got my answer. The largest number that does not work is 30. Lovely. So again, a wonderful question, really tough question, but you hang in there, keep trying. It should possible, it should happen. Fine. Lovely. I'm going to go to the next question. I think there are a few slightly easier questions as we go further. I added all positive integers from 1 to p and obtained a total of 2021. By mistake, I added a number twice. Find the correct total. And so 1, 2, 3, 4, 2, 3, 4, all the way till n. This sum is given by the formula n into n plus 1 by 2. We've discussed this idea over and over again, when we did integers and when we did counting. In both cases, when we did our courses in PiVerb, we have referred to this formula several times. And so it's a beautiful formula. There's a beautiful story with Gauss, a wonderful physics guy and a mathematician. So he's a wonderful guy. So you should look up that story. Beautiful anecdote on this. Fine, from Gauss, G-A-U-S-S. Try that out. N into n plus 1 by 2. So all positive integers from 1 to p is p into p plus 1 by 2. But hey, I've not done just this. By mistake, I've added a number twice. Maybe I added k twice. So the k sitting here, this adds up to 2021. Nice, wonderful. This k should be less than p. I add all numbers from 1 to 50, and then I add another 733, I might get 2021. That's not the case. K is a small number. I missed one of the numbers from 1 to p. Sum of all this is p into p plus 1 by 2. I missed one small number, small in the context of p. What do? P into p plus 1 by 2, I'm going to call it as 2021, and find a number close to this. How do you do? I'm not going to solve it algebraically, put a quadratic equation, none of that. And I'm going to say, hey, let me do 10 into 11 by 2. This is 55, minuscule. Obviously, this is not the answer. Let me do 50 into 51 by 2, which is 51 into 25. 25 ones are 25, 5, 2, 125 plus 2, 127, 1275. That's not it, I have to go to 2021. Break it differently. P into p plus 1 is 2021 into 2. 4042, very close to p square, that is 4042. 60 square is 3600, 70 square is 4900. P into p plus 1 is 4042, I'm getting in between 60 and 70. I'm going to say, okay, maybe 64 into 65 by 2, maybe this is close to 2021. I'm going to try. This is 65 into 32. This 130, 195, add this up. It's 2080, it's become more than 2021, but I'm very close. So hopefully this will be 63 into 64 by 2, which is 63 into 32. 2 into 63 is 126, 3 is 189, add this up. 2 plus 9, 1, 2016, lovely. Sum of the first 63 natural numbers is 2016. So I add 1 plus 2 plus 3 all the way till 63. This total is 2016. I have found out 2021, or I have added 5 an additional time. twice. Find the correct total is 2016. Effectively, we are saying something of the form P into P plus 1 by 2 is very close to 2021, but slightly lesser. Try out different values, find the closest one. 63 into 64 by 2 is 2016. That works because it is just 5 short of 2021. So if I wrote down all numbers from 1 to 63 and then add one more 5 to it, because I've written down 5 twice, I'll get 2021. The correct answer is 2016. Divyan Suresh, can anyone let me know how you were able to prepare for such question before that? PiVerb Advanced is exactly this course. PiVerb Advanced is pretty much this course. There are several PiVerb Advanced students sitting there. So entire course is pretty much an idea of solving a bunch of non-routine questions week after week. We prepare, train, and then attempt these questions. Lovely. I'm going to go to the next one. We follow a new system where A is given 1 point, B is given 2 points, C 3 points, and so on. In this system, any word gets a score equal to the product of all the points sitting inside it. Oh, nice. So if we have a word which is, say, BAG, B would be 2, A would be 1, A, B, C, D, E, F, G, G is 7. The score would be 14, 2 into 1 into 7. We have a 6-letter word with distinct letters whose score is 570240. Thankfully, they've broken that down. 2 power 7 into 34 into 3 power 4 into 5 into 11. The score of the first 2 letters are perfect squares, and the 4th and 6th letters are prime numbers. This word does not have any letter in common with cold or with fat. The 3rd letter is the one with the highest number of points, and the 6th one with the least number of points. Find the score of the word formed by extracting the 4th and 5th letters of this word. Interesting, but I'm already taken in by this. I'm going to attack this. 6 letters, 1, 2, 3, 4, 5, 6. First 2 are perfect squares. So some A square, some B square. I'm not saying A and B, some numbers. They're all different. The 4th and 6th letters are prime numbers. Prime 1, prime 2. Nice. This word does not have any letter in common with the word cold or with fat. Right? Super. 3rd letter is the highest number. Highest. And the 6th one with the least. Lovely. What is the score? Maybe you can find this number. It has nothing in common with cold or with fat. Very nice, very nice. 2 power 7, 3 power 4. I'm going to talk about the perfect squares. We can have each digit going from 1 to 26. And the perfect square could be 1 or 4 or 9, 16, 25. It cannot even be 36. That's not possible. And so 1, 4, 9, 16, 25. These are the possibilities. And so it could be 1. 1 can feature anywhere. It could be 4 because 2 power 7 is there. It could be 9. It could be 16. It cannot be 25 because there's only 1 5 in the product. So A square, B square is one of these. P1 and P2 could be 2, 3, 5 or 11. So the only primes sitting in this number 2, 3, 5, 11. One of these. Or P1 is one of these, P2 is the other. One more of these. Lovely. Now let's attack this cold and fat. What are the numbers that are not there? And so, not there in this system. Cold. C is 3. D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. This is 26, 25. C is not there, so there is no 3 in the system. O, so 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. O is not there, So there's no 15 in this system. L is not there. There's no 12 in this system. D is not there. There's no 4 in this system. No 4, that is very useful. This cannot be there. No 3, that is very useful. This cannot be there. Beautiful. So R with fat F is 6. There is no 6 in this system. A is 1, no 1 in the system. Lovely. So our A square and B square are 9 and 16. Either 9 and 16 or 16 and 9. They've accounted for. Brilliant. The two squares we've got. That makes life super easy. I'm going to use that after we thoroughly eliminate T also. T is 15, 16, 17, 18, 19, 20. No 20 in this system. That doesn't help us anywhere. You could have a 5. Now, brilliant. A square and B square are 9 and 16 that we've got in the bag in some form. So, a 3 square gets taken care of here and a 4 square or a 2 power 4. Remember, it could be 3 square and 2 power 4 or 2 power 4 and 3 square. That's already gone. Just these two letters. 3 is not the prime. 2, 5, 11 of these two primes have to be there. Either 2 and 5 or 5 and 11 or 2 and 11. One of these combinations. 3, 15, 12, 4, 6, 20 are all not there. Look at this. 3 is not there. We need to have 3 power 4 sitting in the system. 3 is not there. 6 is not there. 9 is already there. 12 is not there. 15 is not there. So if we look at multiples of 3, 3, 6, 12, 15 are not there. So if you look at multiples of 3, we could have only 3, 6, 9, 12, 15, 18, 21, 24. 3 is not there. 6 is not there. 12 is not there. 15 is not there. 9 is already there. We need to have 3 power 4 in the system. We need to have 2 more 3's coming in from somewhere. So we could have this or this and this. Both of these have to be there. 21 cannot be there because there's no 7 in the number. If only 24 is there, that's only 1 3. We need 2 more 3's. 3 squares have been accommodated for, but we need 2 more 3's because 3 power 4 is sitting in the number. Or 24 cannot be there, 18 has to be there. Brilliant. Now I know 9, 16 and 18 are sitting inside, and then I'm going to recap this whole thing. Right? So we have 1, 2, 3, 4, 5, 6. 9 and 16 or 16 and 9. Right? And then one of these numbers, digits is 18. Prime 1 and prime 2 are 4th and 16th. P1 and P2 are 4th and 6th. These have to come from 2, 5, 11. One number is 18, that's already there. So we've accounted for 2 power 4 into 3 square into 2 into 3 square. This is 18. These many have been accounted for. 2 power 4 into 3 square into 2 into 3 square. So 3 power 4 has been taken care of. 2 power 5 has been taken care of. And this many have been accounted for already. Our product is 2 power 7 into 3 power 4 into 5 power 1 into 11. Brilliant. 2 power 4, 5 into 3 power 4 is already accounted for. So what is remaining is 2 square into 5 into 11. The remaining has to be in 3 letters, P1, P2 and one more, because 18 is the other letter that's sitting there. Right? Now, we cannot have, the primes could be 2 and 5, 5 and 11, 2 and 11. If 2 and 5 are the primes, if the third number will have to be 22. Right? So, the prime numbers could be 2 and 5, in which case the third number is 22. Or the primes could be 5 and 11, okay, the third number will have to be 4. Or the primes could be 2 and 11, okay, the third one has to be 10. 2 and 11 are primes, 2 and 5 are primes, the remaining is 22. 5 and 11 are primes, the remaining is 4. Of this, we know that 4 is not there, D is not there. This is ruled out. Or definitely one of the primes is 2. 2 is definitely sitting inside. And 2 is the smallest number. This is 2. Brilliant. So 2, 5, 22 or 2, 11, 10. So I'm going to write this all over again. Just to recap. 9, 16, P1, P2. This P2 has got to be 2. Right? So we have an 18 sitting somewhere and one more prime here. This could be 11. That means the remaining number is 10 and 18. Right? The third letter is the one with the highest number of points. The sixth one is the lowest number of points. This is 2. Third letter is here. The score of the first 2 letters are perfect squares. Fourth and sixth are prime numbers. Fourth and sixth are prime numbers. So this is 2. This could be 11, in which case this could be 18 and 10. We could have 18, 11, 10. Or we could have, this is 2, this is 5, this is 22, this is 18. That is another possibility. This one is 2, this is 5, 22 is the other one. That has to be the highest. The third one has to be the highest. Third letter is one of the highest number of points. That is 22. This 18 sits here. One of these two is the answer. 16, 9 in some order. 18, 11, 10, 2. 16, 9 in some order. 22, 5, 18, 2. One of these two is the answer. Is there any way of eliminating one of this? Is one of these right and the other one is wrong? Is there some way to say only one of these is possible? Fourth and sixth are primes. That condition is satisfied. Does not have anything in common with cold or with fat. 18 is not common, 22 is not common, 11 and 10 are not common, J and K, E. Lovely, this is all working out really well. Third letter is one of the highest number of points. Yes, the third letter could be 22, but this could be 18, or 18 and this could be 10. What is this? Find the score of the word form by extracting the fourth and fifth letters of this word. Tricky. So now I'm going to go to the letters. And so what is 2? This is B. And I'm going to write this down. I'm going to go back to this. There's a 9 and there's a 16. 9 is I. 16 is P. There's definitely an 18. 18 is R. There's definitely a 2. 2 is B. And then the last two could be 11 and 10, which is J and K, or 22 and 5, which is B and E. Fine. IP, RB, JK, or IP, RB, VE. Those are our combinations. Fine. So, one second, I'm just having a look. You guys are discussing something else. So IP, RB, VE or IP, RB, JK. And there's something sitting in here. The first 2 letters are I and P, 9 and 16. Either IP or PI, one of these two. So this is IP or PI. The last one is B. And so IP, B, JKR. JKR, this could be K. This is the highest that should be there, RKJ, or I'm going to rewrite this, 1, 2, 3, 4, 5, 6. This is B for sure. This is I/P or P/I. Right? Apart from this, the one other letter that we know is R. The final two could be JK or VE. And IP dash 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 B or PI dash 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 B. Somewhere an R is sitting inside. We could have VE or JK. What is the word we are looking for? We're looking for PiVerb. 16, 9, 22, 5, 18, 2. These two digits are prime. This is the highest. These two are perfect squares. Product is 570240. The word is PiVerb. And so PiVerb, what is the product of the fourth and fifth letters here? These two, E and R, 5 and 18, that should be 90. Lovely. So I still think we have some more questions to finish. I don't know whether we are close to the last one. Oh, we still have. Oh, lovely. This is a tough question. We're not done. And so I think several of you are already discussing the answer. Is there a next level? The next level is what we're doing here. And there is no next level beyond this. This is, I think, Sivacharan. Nalini Sriram is already banning someone from PiVerb. So the answer is PiVerb, PiVerb. Right? Lovely. Let's do this one. A sequence has the first term 2021, after which each term is the sum of the squares, the digits of the preceding term. As the first three terms are 2021, nice. And 9, 2 square plus 0 square plus 2 square plus 1 square, 4 plus 4 plus 1, 9. Next term is 81, 9 square. Find the 2021st term. It's a nightmare. Right. Let's do this. 81. Next term is 8 square plus 1 square. 8 square plus 1 square. 64 plus 1, 65. Next term, 6 square plus 5 square. 36 plus 25, which is 61. Next term is 6 square plus 1 square. 36 plus 1, 37. Next is 3 square plus 7 square. 9 plus 49, 58. Next is 5 square plus 8 square, which is 25 plus 64, which is 89. Why am I doing this? Why am I continuously filling numbers? Why am I? Because I'm looking for one thing specifically. What is that one thing? I know each number is generated from the previous number. 2021 generates 9. 9 generates 81. 81 generates 65. 65 generates 61. 61 generates 37. I know the moment I have some one number repeating, there will be a pattern. If I have a 58 here, if I get one more 58, immediately after 58 will be 89. Immediately after 89 is whatever follows that. So I know that the moment I have one number repeating, I'm through. So all I'm going to do is keep on filling this. I was hoping to find some number repeating soon enough. That's not happening, but let's hang in there. 89, 8 square plus 9 square, 64 plus 81, which is 145. Got 3-digit numbers. Now 145, 1 square, next number after 145, I'm going to erase this side so that we have enough space. All this we have done, we're just squaring the previous term and adding it. The next number will be 1 square plus 4 square plus 5 square. 1 plus 16 plus 25, which is 42. The number after that is 4 square plus 2 square. 16 plus 4, 20. After that is 4. 2 square is 4. Next is 16. The next number is 1 square plus 6 square, which is 37. The next number is 3 square plus 7 square is 58. Next number is 5 square plus 8 square, 25 plus 64, 89. I've done this before, I can see it happening. I'm done. Why? Because there's a 37 here, there's a 37 here. There's a 58 here, there's a 58 here. There's an 89 here, there's an 89 here. The number after that, after 89, will be 145, which I have not written down. Then 42, then 20, and so on. I'm done. I found a beautiful pattern. I know that the moment I have a 37, everything repeats in the same pattern after that. So I have 2021, 9, 81, 65, 61. 37, 37, 58, 89, 145, 42, 24, 16. This is the block. And then I'll have this repeating. So I have 1, 2, 3, 4, 5, 6, 7, 8 numbers repeating in a block. So I'm going to rewrite this whole sequence. Take care of these 6 pesky numbers outside. And so what I'm going to do, I'm going to say 2021, 9, 81, 65, 61. Keep these 5 numbers aside. After 61, I get 37. After 37, oops, I have 58, 89, 145. 58, 89, 145. After this, I have 24, 16. 24, 16. After this, I'm back to 37. 58, 89, 145, 24, 16, 37, 58, 89, 145, 24, 16. I go in steps of 8, chunks of 8 come through. That's it, I'm done. So effectively, I know my 6th number is this. So my 14th number is this. 22nd number is this. 7th number is this. 15th number is this. 23rd number is this. 8th, 9th, 10th, 11th, 12th number is this. 20th number is this. 28th number is this, and so on. Sorry, 6, 7, 8, 9, 10, 11, 12. 1 second. Maybe I missed a number. 37, 58, 5 square, 89, 145. Missed a number. After 145, I've missed a number. Oops. This is going to. After 145, I have 42, then 20, then 4, then 16. 42, 20, 4, 16. 42, 20, 4, 16. So 6th, 7th, 8th, 9th, 10th, 11th, 12th, 13th, 21st, 29th, and so on. All we've got to do is find where our 2021 sits. I divide by 8 and get the remainder. So I put 2021 divided by 8 goes 2 times 16, 42, 5 times 40, 21, 2 times 16, the remainder 5. 2021 is of the form a multiple of 8 plus 5. So it will come in the sequence 13, 21, 8 plus 5, 16 plus 5, 24 plus 5, 32 plus 5, 40 plus 5, and so on, which is this number. So it's a multiple of 8 plus 5. Each of this is going in steps of 5. Multiple of 8 plus 5, 13, 21, 29, it will hit in this sequence, or my 2021st term is 16. So this number 2021 is of the form a multiple of 8 plus 5. There are 5 terms here. You leave out those 5 terms, then I'm talking about the 2016th term, leaving out 5, 2021 minus 5, which is a multiple of 8, last row sitting here. So the answer is 16. Wonderful question, nice tough question. Key point here is to recognize that, hey, I'm going to have this pattern repeat. I'm going to wait for the repetition. Right? Lovely. Let's go to this one. 1, 2, 3, 4 till 20, 2021 are written on a blackboard. Some 2 numbers are selected randomly and replaced with the difference between the 2 numbers. If we selected 52 and 30, we would erase both and write down 22 instead. So 1, 2, 3, 4, 5, 2021. We erase some 2 numbers randomly. Right? And then the last remaining number, what could this be? We take some 2 numbers and replace it with a difference. Now, my answer choices are 1, 2, 4, 8, small numbers. I want to eliminate all the large numbers. What will I do? I'll say from 2021, take 2021 and 2020, subtract this, write down the difference. 2019 and 18, subtract, write down the difference. 2021 minus 2020 is 1. 19 minus 18 is 1. 17 minus 16 is 1. 15 minus 14 is 1. All of these are 1. But 2021 and 2020, I'm replacing it with 1. All the way till 3 minus 2 I'll do. I'm pairing it up. Every pair gives me a 1. Finally, I'll have this 1 remaining, and I'll have how many pairs are there? 2020 numbers I'm pairing up. 2020 by 2, 1010 ones will be there. Nice. So I have 1011 ones with me. Now I'm going to do the same process. What do? I take all these ones, pair them up, I'll get zeros. I have this one, I'll retain, I'll have zeros 505 times 1010 by 2. 505 zeros I have. All of these are zeros. I take any pair and I'll get a 0. I'll finally subtract everything, keep on eliminating, I'll get 1 0. 1 minus 0 is 1. My answer could be 1. I can get a 1. The question here says, I keep replacing. Which of the following could be the last remaining number? Could be. I'm not saying will be. Which of the following could be the last remaining number? It could be 1. This is a way of saying it could be 1. I'm trying to find one number. It could be 1. Now I'm going to establish this. And so I have 1, 2, 3, 4, 2021. Out of these, I'm selecting 2 numbers. And there are 3 ways of selecting this. I could select both numbers to be even, both numbers to be odd, 1 even and 1 odd. Nice. Both numbers could be even, both numbers could be odd. There could be 1 or even number, 1 odd number. Right? If both are even, the difference between these 2 is even. If both are odd, difference between the 2 is even. There's 1 even and 1 odd, the difference is odd. So I'm taking these out and replacing it with an even number. Taking these 2 out, replacing it with an even number. Taking these 2 out, replacing with an odd number. I'm only thinking about even numbers and odd numbers. I'm not thinking about the magnitude at all. Right? Now what happens to the total number of numbers? Here, I take out 2 even numbers and replace with an even number, or whatever total numbers I have, when I do this process once, I'll subtract minus 1 even number. Or if this happens, I subtract 2 odd numbers and add 1 even number. If this happens, I take out an odd number, I put in an odd number. Odd number count does not change. I'll subtract 1 even number. So whatever number of numbers I have, I'll either subtract 1 even number, or I'll subtract 2 odd numbers and replace it with 1 even number. I'm taking away 2 odd numbers and adding 1 even number. The beauty here, even numbers are appearing in every transaction. Right? And steps of 1. Odd number, either the number of odd numbers does not change at all, no change, or it drops by 2. Right? Either the number of odd numbers reduces by 2 or it stays as it is. In 2021, that's an odd number. 2020 by 2 is 1010. So in 2021, there will be 1011 odd numbers and 1010 even numbers. Whatever we do, will either reduce the number of odd numbers by 2 or keep it as it is. So from this 1011 odd numbers, I'll keep on dropping 2 odd numbers, or I'll do nothing to it. Think about it. You can never really eliminate all these odd numbers. You cannot. An odd number of odd numbers. You're either eliminating 2 or nothing. It goes down in steps of 2 or steps of 0. It can never go to 0, or my last number has to be an odd number. In the end, whatever sequence I do it in, my last number has to be an odd number. If you look at the choices, I have 1, 2, 4, 8. Even number, even number, even number. Only 1 odd number. My last number has to be an odd number. That is the one I'm looking for. Wonderful. I hope we don't have any more questions. We do not. So I'm going to sign off. It has taken longer than I thought it would. And so I'm sorry about that. We spilled over by about 8-9 minutes. Lovely. I'm going to sign off now. Good to catch up with all of you. You've been wonderful students. You've participated in the chat. You've discussed questions, answers, solutions, all of that. These are delightful questions. Really, really, really tough questions. If you've got one correct, then you should pat yourself on the back. If you've got 0 correct, but you tried several questions, you should still be super thrilled. Don't be governed by marks and scores and ranks and percentiles. Think in terms of, hey, did I learn something? Did I get a new idea today? Can I think in terms of even numbers and odd numbers? Can I eliminate and find letters and words and numbers? If I can do all that, then I'm good. And so focus on. Okay, so I've been told how to, I should tell you how to access the answers. Go back to PiVerb.com. You know your user ID and password. Click it in. Click on the course. Now you can click there and you'll be able to find your scores and you'll be able to find the answer key. This video, you can access it anytime to see the solution. Worry less about answer key, score. Worry more about understanding the solution. Solution and the idea you learn from it is going to stay with a lifetime. This answer key, you'll forget. The idea of approaching a question, that's going to stay. So keep that in mind. So difficult that, remember that you're going to take value if you understand thought processes. And don't worry too much about marks and scores. Having said all that, you go there and click. Wherever you took this test, click there and check out the answer key or explanation or solutions. You should be able to see your score. You should also be able to see the solutions on this YouTube link. You just scroll up and down, you can find all that. Right? So I had a lot of fun solving this. I had tons of fun creating the questions as well. My favorite question was the first one, the multiple of 11. I like the last 2 questions as well. And I obviously like the PiVerb question, the answer for which the word was PiVerb. So 16, 9, 18, 5, 2, and 22. PiVerb. That worked really well. So many congratulations for all of you who have taken part in this and kind of hung in there and participated in this, which is super good, super useful. I'm not going to at all talk about the scores. Those of you who've got great scores, great. Those of you who've not worried about, who've not got great scores, still great. Don't worry about the scores. You're too young to worry about some mark and score. Don't worry about it. Don't discuss scores. Don't discuss marks. We're probably not going to put marks or ranks anywhere. Those of you who have done well, we would send across some nice, some reward, award, gift, something will be there. But if you ask me, if you've learned these ideas, you're in a good place. If you have to learn, you have to learn to enjoy, learn to say, hey, this is thrilling, this is interesting, I figured this out myself. This is super tough, but I hung in there. I could have given up after question number 3, going nowhere, but I somehow hung in there and got 1 question right. And next time around, I'm sure I'll get 2 right. That's brilliant. And getting 2 questions right in this test is remarkably good. When I was preparing for several of my exams, till class 9, class 10, we were all a bunch of good students. In our school exams, you would get 85, 86, 90, whatever the good mark was. We would miss and compete and all that, but we were not cut adrift. But when we started writing these tougher exams, preparing for the entrance exams, we would take question papers where there are 50-mark paper, and on the top score would be 19, the average score would be 4, and you would get 7, and you will feel like, look, I've got 7 out of 50. But the key is to say, okay, I've got 7 out of 50. It's still better than 4. I think if I make these corrections, I can go to 14, 15. That's an extraordinarily good mark. I need to learn to hang in there and get those 2 marks, 3 marks. And that's that shift of saying, look, I need to persevere and understand and figure out and learn and not really worry and get turned off by a mark or a score. That's important. In many ways, but one of the stated, unstated objectives of PiVerb Advanced, the course and this Olympiad, everything, is to remove the fear of a low mark from our students. And just, you got 3 out of 30, great. You got 0 out of 30, good. I knew I was heading towards 0. I attempted till minute number 59, and I kept trying. And I know that because I tried that, I can take a lot of value from this course. And you'll be a star, take my word for it. If you attempt this paper for 60 minutes, you're doing phenomenal. Don't worry about mark scores at all. We're not going to send a detailed scorecard and all of that. I like the idea of analyzing scores at an overall level. Individual scores don't matter. And so don't let them matter. Make sure that you hang in there. Lovely. Namaste to all of you. Many thanks. You've been a wonderful audience. You've hung in there for this long doing all these solutions. Some of these questions are super, super, super difficult. I can tell you that I've finished engineering. I prepared for 2 years for my joint entrance exam. I did an MBA. I've been training students for non-routine questions or math questions for 12 years now. And if I had taken this test, there's a good chance that I've got 5 or 6 right and the remaining wrong. And this paper is that difficult. So don't worry about your score at all. Enjoy the process of learning the math. And I'm sure Raghu or Bala or Avinash or Prabha will tell you the same. These papers are good, tough. We want it to be tough. We want you to not get turned off by not getting answers. Fine. I hope if they've drilled one thing through, it is that. Hang in there, keep trying. Don't worry if you get some things wrong. Don't worry if you don't go anywhere. Wonderful. You've been a fabulous audience. You know where to check out the course, where to fill the form to inquire about this. We do this practically every week. We do a set of 10 questions and discuss them. The 10 questions that we did today are tougher than what we do on a week-on-week basis. Every week can't be this difficult. This is unnervingly tough. Every week is more regular, but we teach ideas, we create the building blocks, and then do a bunch of tougher questions. So it's a very, very exciting course, super interesting. I enjoy myself teaching it. So you guys should definitely try that out. Wonderful. Am I an alumnus of DAV? No, I'm not. I like your school. I like the DAV group of schools. I think they stand for the right things. They do a lot of keen things academically. I like the idea that you just say namaste and you treat each other with respect. I like the way the teachers handle the students. Several things I like and admire about the school, but I'm not an alumnus from that school. I went to this, my father was in a bank. I studied in 8 different schools. Nice to meet all of you. We have one more session this Thursday, which is for slightly simpler questions for classes 6 and 7. But hey, if you want to attend that, you should be giving it a shot. The questions are still not easy. Maybe you guys might get 4 or 5 questions right out of 10, but I'll be very surprised if you guys got 10 out of 10 because even that is difficult. And that's going to happen on Thursday, same time. So if you're free, you should drop in for that. That promises to be awesome fun as well. I'm not going to announce prizes. You will get prizes by email. I've been standing here saying, don't worry about your marks. So I'm not going to say, hey, so-and-so has got 24, 27, 21, all that. I know the average scores are close to 0. And so I know the maximum number of people have got score 0. That I know. I'm not at all unhappy with it. I'm glad that you guys are getting to see 0. You're all star performers. You're all excellent students. You're going to be wonderful, upright citizens. And if you get a 0 along the way, there is nothing to be ashamed of or feel bad about. You take in your stride and say, hey, I got 0, I tried, I learned. The adjectives and the verbs are different. I tried, I learned. I was curious. I am interested. Those are the key things. I scored this, I underperformed, all those nonsense. You don't worry about those words, those objectives, those adjectives. Nice. So the maximum number of scores, maximum score 0, which doesn't matter. And then quite a few have got 1 question right. So about 80% or 70% of people have got either 0 correct or 1 correct. So don't worry about your scores. It doesn't matter. Lovely. The leaderboard, I don't know. The leaderboard is not in my hands. If it were in my hands, I'll say don't give the leaderboard. I don't want a leaderboard. So you will know what you have scored. So don't worry about it. We'll come up with some statistics at an overall level and discuss it and share it in a blog, mail it to you, so you'll know how many people have got what score. I'm not going to say who got what score. You don't believe in it, nor should you be overly concerned with it. Please tell us when the next Olympiad is. Next Olympiad discussion is this Thursday. At PiVerb Advanced course, every week is an Olympiad. So if you like the Olympiad experience, you should probably jump on and take the course. Lovely. I'm going to sign off. Wonderful, most wonderful experience I had talking with you guys. Now, next time around, I already have a bunch of ideas swirling in my head about what we'll do in the next Olympiad. Hopefully, I'll catch up with you guys in 6 months' time with one more edition of this. Hopefully, I'll see several of you during class where it is a more open environment where we can discuss and chat and do something on Zoom and chat about what you like, what you don't like, learn new ideas, not just solve, and create the building blocks to be able to solve this. Fine. With that, I'm going to sign off. Good to know that you're all enthusiastic and keen to learn. Hang on to that attitude. We'll catch up with you next time around. Sure.